Well, we're going to investigate polymer plastics. And polymers are everywhere. They're ubiquitous in our daily lives. You probably run into these. These are really tough. I mean, you ever tried to mess with it? How about saran wrap? Have you ever messed around with saran wrap? It's tough stuff for its weight. And why is that? Well, if you look at the atoms, you would see that the atoms are long chains of atoms, very similar to like these paper clips that are linked together. But they're not just long chains of paper clips. They are actually cross-linked, almost more like this mesh here, and that gives them strength. Otherwise, you could just reach up and tear them apart, like you can paper or something. You just reach up and go like that, and that wouldn't be, that's not what this is. This is a lot tougher than that. So it has to do how the cross-linking and how the atoms are bonded together. So we're going to do a little lab. You're going to make some of your own polymers. It's a great lab. Probably want to wear your goggles. It's one of those deals where you want to be safe. And it's a relatively easy lab to do, and a fun lab. You're going to make up some 1% calcium chloride solution, and you're going to make up some 2% sodium alginate solution. Now, sodium alginate is made from dried kelp, and they take kelp and they chop it all up and dry it all out and turn it into a powder. And when you mix it with water, it makes kind of a gooey consistency, kind of a colloidal liquid. It's really interesting stuff. Well, when you add that to sodium or calcium chloride solution, it's going to make gel. And it is, by the way, edible, although I don't know that I would eat it. As far as I can tell, it kind of tastes like salty seaweed, which not my flavor. But I'll give you here. Let's give you an example. So first of all, you're going to take your sodium alginate and pour it into a beaker. It isn't that good looking stuff. You're probably going to need a dropper. Fun stuff. Looks gooey. And then you're going to need some calcium chloride solution. And I'm going to pour it into a petri dish. So this is my 1% calcium chloride solution. I'm going to put that in here. And then we'll add a little bit of sodium alginate. At least we'll try. Oh yeah. And you're going to get some very unique stuff. And try not to get it. There we go. Oh, look at that little guy. And as you keep doing this and adding it, there's going to be a very quick chemical reaction. And you're going to get some very strange stuff. Like, I made green worms. Now, what middle school kid wouldn't want to play around with some green worms? And make your observations and check out making polymers. It's a very interesting material. And this lab was created by a professor down at Oregon State. And go Beavs, of course. And polymers, we're always finding new uses for them. So maybe someday we'll be able to use polymers to make an artificial kidney, for example. You never know. So mess around with this. Maybe you can figure out some new use for this. I know for a while they were putting this in soft drinks, and everybody thought those were really cool there for a while. I don't know if you remember Orbits or not. But fun stuff. Make some observations and check it out.